Hey everyone. So I think most of you know, but this is ThoughtWorks. Welcome to ThoughtWorks. We're a software development consultancy. So we do all kinds of crazy stuff. If you want to learn more, then feel free to talk to me or talk to Chandni here and learn more about it. And we're happy to be hosting the Sandstorm meetup. And I'll hand over to Amy.
Yeah, thanks again to ThoughtWorks for having us. And thank you so much for coming to the Sandstorm meetup. Just a save the date for our July meetup. It'll be on Tuesday, July 19th in Mountain View at Reed Lake DB. So save the date, and the meetup is there for you now to RSVP. So without further ado, I'd like to turn it over to Drew and look forward to Dems at Sandstorm.
Hi everybody, I'm Drew. I'm one of the Sandstorm core devs. It's exciting to have all of you out here today. I'll be talking about how you can build secure systems with object capabilities and Python and Cap'n Proto in particular. And so a little bit about myself. I'm Drew Fisher. I earned my master's in computer science at UC Berkeley. I worked with Dave Wagner and Bjorn Hartman in human-computer interaction and security. And I am a software engineer at Sandstorm. I work on a little bit of everything, as I think we all do when you're a small company. In my free time, I am a puzzle hunt enthusiast, and I enjoy writing and playing in puzzle hunts, some of which I've written with Python, which was one of the reasons why I was excited about giving the same talk at PyCon a couple weeks ago. So this talk will cover a bit about what object capabilities are and what they're good for and how we can use them to improve the design of your software, make it easier for you to get things right and harder for you to get things wrong, and then talk a little bit about some examples and applications of how we at Sandstorm use capabilities to model interesting things in the real world. So theory first, and with apologies to the capability experts in the audience, for whom this will all be old hat. What are object capabilities? A capability is an unforgeable, communicable token of authority which references an object and a set of access rights. We'll go into each of these in detail, but at the high level, a capability is a handle to a thing that you have permission to. So, unforgeable. The unforgeable aspect of a capability means that you can only obtain one through the system's intended means. So it could be something where you're running on top of some sort of platform which guarantees the validity and is responsible for interpreting whatever this capability is. Or it could be something which is valid to any bearer, but unforgeable by property of having too much entropy that you would be unable to reproduce it before the heat death of the universe. So, capabilities are communicable. One of the key properties that lends to their usability is that they are transferable to other agents to support delegation. And I want to quote another capability enthusiast, Mark Stiegler, who gave a talk in which he gave this amazing quote: "The truth of the matter is, delegation cannot be prevented. The further truth of the matter is, we do not appreciate how fortunate it is that delegation cannot be prevented, because in fact, delegation is the cornerstone of civilization." And if you take away one thing from this talk tonight, it is that your software needs to support human delegation. People delegate responsibility, your human processes require delegation, and so your software needs to be able to support the same sort of human delegation for it to be able to properly support what people need the software to accomplish for them. A capability is a token of authority. We have already done an access check before we've issued it. Once you have it, you can use it, you are already authorized. possession of the capability proves that you are already authorized. And a capability refers to some specific object and the access rights that you have on that object. So there is no making requests about objects without context, without some unit of authority that this capability provides. So we went through that definition. What's the big idea? The big idea for usability is that capability handles can be transferred between actors because delegation is super important for people actually getting real work done. And then there's also that new capabilities can be generated dynamically at runtime to express behavior that grants of permission that are impossible to express with static rules.
Terminology. You've explained capabilities. In this slide, you said capability handles, and if you just said capabilities.
Capabilities.
Yeah, so I'm wondering, is there something specific you mean by capability handles?
No, I mean capabilities, I believe.
Okay.
So if your system doesn't support delegation, then people will work around it. So if you have a system where you can't modify access controls, then people will work around it by copying the content of whatever it is that they wish they could share. And users tend to understand what it means to share a thing that they have access to. So capability-based systems make the system model match the user's mental model of how a thing is supposed to work. And that leads to lower friction when people are actually trying to use your software. There's less of an impedance mismatch. So those are the things that can make capability-based designs more usable to real people. And there are also some nice security benefits that we get from this design pattern as well. The biggest one, I would say, is that we make the principle of least authority actually practical to implement. The principle of least authority states that no component of a piece of software, no actor in a system should have more authority than what it actually needs to have to do its job. So ideally, if you're editing a file, then you should only be able to access that one file. If you are running a network service, you should really only be able to bind to that one port in an ideal world. Anything else means that you have some permission which, if your program has a bug or if your program gets confused, then it will do something that was unintended, and that might cause harm to a user. The other big idea is that we want to make it hard or impossible to express unauthorized actions. So one of the challenges with making systems secure is that we tend to build things where we build the functionality and then we build the access controls later, or separate, or it's a different team that's building them. And what that means is that you can wind up with this mismatch where you've successfully written the access code, but you haven't successfully written the access control code. And so users are able to express that they want this action to happen, and instead of being denied by the access controls, the thing happens anyway, and now you've got a privilege escalation, you've got some sort of security violation. With capability-based security, since you already have the capability before you can express that action, you've already done the access check. And so actions that are not supposed to be something that you can do become impossible for you to request from the system at all, which makes them much more difficult to exploit. And the other piece is that the security model gets to reuse object-oriented design patterns, which we think software developers in general understand fairly well, to reason about authorization. You have access to an object, then you can call its methods. Instead of having something where you might have a handle to an object, but then have some entirely orthogonal system that's determining whether you're allowed to take some action on it. So some examples, things which are capabilities. Unix file descriptors are perhaps one of the canonical examples of things which behave like capabilities. They're unforgeable. The kernel decides what file descriptor number to issue to you, your process, and reusing that number in another process does not mean the same thing to the kernel. It decides what that file descriptor means. They're transferable. One of the lesser-known properties of file descriptors is that you can send them over Unix domain sockets with send message. This allows you to transfer or to open a file in a higher privileged process and then pass it over the socket to a lower privileged process that wouldn't be able to open it itself. But because you sent it that handle, now it can take actions on just that one file that you provided it. It's a token of authority. Once you have a file descriptor, the various syscalls for interacting with them don't need to check if your user has authorization to the file reference. They just look up the rights in the kernel's file descriptor table. And the kernel knows what resource that file descriptor represents, regardless of whether it moves on the file system or means something else. And the kernel knows what syscalls are legal to perform on any given file descriptor. So that's our list of 5 things. Unix file descriptors are capabilities. Great. I'll give a slight honorable mention to some things which have some of these properties, but not all of these properties, because they're interesting to review insofar as getting some of these properties gets you some of the security benefits that you might like, and so it might be a practical trade-off to look at some of the other things that people do. So I'll name OAuth tokens. They're not quite object references the way people usually use them. It's possible that you could make for, say, a storage API, a separate token for each file that you might interact with, but this is less commonly done, particularly for user-facing services. They are, in a sense, delegatable. You copy the bits and you use them elsewhere, and you have the access token. Then you can make the requests. They are unforgeable by nature of being secure, random, long, entropy-full strings. They can be limited in scope, depending on how the API is designed. And so we could say, yeah, these things have some of these properties. They're not really like capabilities. We wouldn't say that frequently your API that supports OAuth might have another system that isn't OAuth that it uses to also authorize requests, and so that's less great. But within this context, a lot of these things are somewhat capability-like. Let's talk about some things which are definitely not capabilities. File paths. File paths are perhaps the root of all file path traversal vulnerabilities. They are forageable. Anyone can name any file, and it means the same thing to everyone, unless you're using file system namespaces or something like that. But I can ask to open Etsy Shadow whether or not I have permission, and something has to decide whether I should be allowed to read or write it. Their file paths are communicable, but even at different times, they may refer to different objects. So I could send you a path, but that the file referenced by that path has been replaced by a symlink that points somewhere else when you go to look at it. And so there are time of check, time of use bugs. They're not object references, and possession of a path does not imply rights to the file. So basically, X's in all the columns. URLs are...
I have an annoying interrupting question, if that's okay.
Go ahead.
If you could just add Etsy shadow hash some token, that would solve your problems.
If you uniquely identified each file with some other unique ID, which is unforgeable and strong random, then you've basically done away with the purpose of that /etc/shadow string, and maybe you should just identify it by the random bits entirely in your flat namespace.
Fair. Okay.
So, So URLs are also generally not capabilities. They're forgeable for the same reasons that paths are forgeable. They typically do not carry rights in the URL itself, but through some orthogonal authorization scheme, cookies, or some other header. We see a lot of OAuth systems use bearer tokens in an authorization header. And even if you created unforgeable cookies, now you have this other problem of ambient authority, wherein you can't distinguish an action which the user is authorized to do but doesn't mean to do from an action which the user does mean to do and is authorized to do. This is why in many websites, all of your forms wind up needing a CSRF token, the cross-site request forgery token, to make it so that other sites, which might embed a form that would post to the same server-side URL, can't pretend to be the site can't pretend to be your site generating that request. The user's browser sends the cookies anyway, and so if you're just using the cookie authentication, then you might take an action that the user didn't want. A common example that I've seen is log out. If you allow log out via a GET request, then anyone can iframe that path, and
it's
then
a popular troll inside Google. Like on their whole system log out, so they've logged out of all services inside the company.
So, and this is why we wind up having to do cross-site request forgery tokens, because URLs aren't capabilities. I'll make one exception, which is some URLs actually do have strong random bits in them. Password reset links, you could consider a capability to take the action, reset this particular user's password. It's unforgeable, the URL is the token of authority, it covers precisely what you are allowed to do with it, and the user associated with that token, so checks the boxes. So we've talked a bit about what are capabilities and what aren't capabilities. Let's compare capabilities with what you would probably otherwise use, which are access control lists. And so what you're looking at is known as the access control matrix. You have some principals on the left, some users. You have some resources on the top, the columns. And then you have whether that user should be allowed to access that resource as yes or no in each of the cells. And so you might think of access control lists as the columns associated with each object. So you'd see something that looks like this. These green rectangles are an access control list associated with that object, and it refers back to the users that are permitted access to it. And so this is that same matrix that we saw in the previous slide as an access control list graph. And so what capabilities, you could think of a limited form of capabilities as being the rows, as mapping instead of from objects back to users, from users toward objects that they have permission to. And so under static assumptions, you can say that these are equivalent. But an important thing to note is that we don't always work in static systems. In capability systems, we also think about dynamically passing capabilities between actors. And what that lets us do is something much, much more powerful. So here we have Alice and Bob and Carol. So let's think of this hypothetical scenario where Alice and Bob are working on this shared document, home Alice shared.txt. And right now, you can see in the ACLs model, they both have access. And in the capabilities model, they both have access right now. And then Alice goes out of town. Bob needs to get Carol's feedback on that document, or Carol needs to make some edits to it. How do they do it? In the ACL system, you've got a problem, because Alice is the owner of that document, and only Alice is allowed to change the access control list. So Alice needs to change the ACL, but Alice is unreachable. So how does Bob solve this? Bob makes a copy of the document. Now Bob shares that new document with Carol, and then has to merge whatever changes Carol makes back into the original document. Your system has now lost provenance of these changes. You've forced people to do a bunch of human work to actually merge these changes together, and so you risk having out-of-date data. If when Alice comes back and Carol makes more changes, does Bob know to sync them back so that Alice will see them? It's troublesome. In a capabilities model, instead, Bob creates a new capability based on his capability to the shared document and passes that to Carol. Now Carol can act as long as Bob still has authority to that file. Alice didn't have to get involved. So we've managed to support the human requirements of the workflow in a way that the other system did not. Oh, and just one other thing, you can say, well, isn't it like a security problem that Bob would be able to share with Carol without Alice's authorization? And the answer to that is you can't prevent delegation. We saw the previous example where the system thought that only Alice and Bob could see that file, but in fact, Bob and Carol could also see this other file that was created. You want to make the bits uncopyable? Okay, Bob will share Bob's login credentials with Carol. And so you can't get around people getting their work done. That's the important thing your software needs to support. So better to get out of the way and let them do it well. You can provide systems where you might have Alice express a preference that Bob not redelegate this. But at the end of the day, this is a human problem, not a system problem. So capabilities are great. They are harder to implement incorrectly because you have to have thought about access controls and who has access to what and what gives them that power up front. They're more expressive, they compose well. If I have a capability to a folder, I could create a new capability to a single file in that folder, perhaps, and pass just that one. And they allow for fine-grained controls and delegation. There are some criticisms. Some of them are false, which I'll talk about first. Some people think that revocation of capabilities is infeasible because you've already given out this capability. How do you can't claw it back? You can't modify the table that is no longer under your control. And the answer to that is that there are systems in which you can have a capability where you have the ability to invoke a revoke method on that, and then future calls that the person that you delegated to will be no-opt or will refuse to take action. And so revocation is perfectly possible within a capability system. It's a little more overhead. You might have to think about it, and you might have to express this in your code, but it's totally possible. And we already covered that ACLs are not equally expressive. They are identical under static conditions. They are not the same under dynamic systems, and we live in a world of dynamic systems. They can be a little harder to implement. We've spent a good amount of time building these things. And we're still learning exciting bits and pieces, the details of how to make them accessible. You have to think a bit more upfront, which means that some of the economics of building a new system might push you away from this. I think that in the long run, the lower code maintenance of having a capability-based system is more valuable than that benefit that you might get from not building an authentication system at all up front, but it is a trade-off that is worth considering. And so it might take a little more time for you to actually build that thing of interest that you are interested in constructing. And there are fewer widely deployed capability systems in the world. There's less reference documentation on how you might build a thing. Question?
Yes. Is there some kind of study or research about the cost difference of creating and maintaining two systems with equivalent or semi comparable functionalities?
I don't know of any offhand, but perhaps some of the other folk who...
I don't know of any.
Yeah. I suspect that the challenge in getting good data there is that most companies aren't going to be interested in maintaining two copies of the same thing for a long period of time. So,
Are you willing to include the security vulnerabilities of the Apple model in the cost?
Yes, I'm thinking about the not just incidental cost for the CapEx you lay out, but the OpEx and the maintenance down the line. What is the lifetime of the system? Is it just 5 years, or because after 5 years you're done with your IPO and you're out? Who cares?
Well,
is it a decade or 2 or 3?
Well, the reason I was asking was there are no studies on the relative costs of the two systems, but there certainly are studies on the cost of the security vulnerabilities in the Apple model.
Yeah.
So that's part of the answer.
That's fair. Thanks.
I guess in some sense, Sandstorm is an experiment to show that the capability model is viable long-term for larger code bases. And
there's also the fact that any sufficiently complicated and developed Apple system will include a bad capability model somewhere inside. And a sufficiently complicated and developed capability system will include some sort of Apple simulation inside. So at that point, is either one really? I don't know.
So there are two ways to express duality, and you choose your poison.
In a sense.
Well,
I'm just kidding.
Yeah.
I want to move on and talk a little bit about Python in particular, and how you might try to apply some of these abstract things that I've been saying to some real system designs, and how you might think about structuring your programs in a way that's more capability friendly. So, raise your hand if you've written an app with Django before.
Yeah.
Yeah, maybe some hands. Okay.
Flask more.
Flask. Okay. Flask also has a similar syntax for doing this sort of thing. So you've got this hypothetical route, admin users list. It gets a request coming in, and then it replies with some rendered HTML of the page that you wanted. And it's got this decorator staff member required, which says that for you to be able to see this route, you need to be logged in as an administrator. So now the catch is, it's really easy to forget that @staff member required. If you're looking at it in a code review, it's pretty hard to notice the absence of things as compared to the presence of wrong things. And so you might wind up, you're not actually doing anything with the user object here, so you might not notice that anonymous users now have access to your entire database. Yikes. So it's pretty easy to accidentally wind up with this sort of security problem. Something that might work better is if instead of declaring your routes and then specifying access controls on them, if instead you authenticated your request and then based on the user, you looked up what routes they should be allowed to access. And so then you could think about organizing objects by what your authority permits you to see. So you might have some anonymous routes, just an index page and a login route. And then if you post to login, then perhaps you get a new kind of session, a user session. And then the user routes can include these, and so on for admins. And you'd notice in a code review if this line were up in your anonymous routes. there's much less question about whether that would subtly go unnoticed.
I just want to mention, this is a new point. I've never seen this point before. That even just looking at from a static rows versus columns,
Oh, yes.
that you still have a significant benefit here. I've never heard that point before.
Okay, yeah, the difference is that in the capability model, everything fails closed, whereas in the access controls model, or at least the one adopted by most web frameworks in Python, fail open because that's easier to get something up and running initially. So, yeah.
Yeah, very good.
So, PyCap'n at Sandstorm, we use a capability system implementation that is Kenton's brainchild called Cap'n Proto. It's also based on some of the previous work in the field E language, and CapTP, and
Should be his work.
which is Mark Miller's work. Acknowledgements all around. So to use Cap'n Proto, you define your object interface and your schema in some .capnp file with a custom domain-specific language. And then from your code, you import that schema, and you can use that, you specify interfaces, which you can have a client for or a server for. And then your client can send calls, and your server implements code to run when that kind of call is received. And there are some examples, which if you want to look at these slides later, I'm happy to show you. I'm just going to talk briefly about the high level, what we do in Sandstorm with these. One of the things that Sandstorm does is it translates HTTP requests on sockets into Cap'n Proto RPC calls through an interface we call web session. And so a web session has some data associated with it, like the preferred language, and it has a bunch of methods like get and post, and each method might also send some context. So what you might consider the headers that you would send, or a post body, which might be streaming. And we send that all over Cap'n Proto RPC. And one of the cool things that we can do as a result is we can apply the capability model to individual backend services. We achieve this by, we said earlier that URLs aren't capabilities, so how do we do that? We stuff them into an unforgeable namespace by requiring a wildcard DNS record for the server so that we can generate an infinite supply of high entropy domains. And requests for user sessions can only go to one of these sessions, which acts, to one of these domains, which acts as a capability to that session. I'm eliding some details about additional defense in depth that we do, but the high-level picture is we have retrofit a capability model onto an existing non-capability system by creating an infinite namespace. So web session is what we do to represent HTTP requests. We also have some other interfaces, and one that I think will demonstrate the principle of least authority that Sandstorm and capability-based security let you have. We have an interface IP network, and you can, if you have an IP network, you have full outgoing network access to any server on the internet, any port, TCP or UDP, whatever you like. And it has these two methods, get remote host and get remote host by name, and these are basically your connect to an IP or connect to a DNS record. And you have, from them, you get returned one of these IP remote hosts. And an IP remote host is a capability which lets you connect over TCP or UDP, but only to that host, only to that single server now. And so it has these methods, get TCP port and get UDP port, and those return a TCP port or a UDP port, and a TCP port is the ability to connect to just one host on the internet on one port. And note that when you hold a TCP port, you don't actually have the ability to ask who that is at the other end, this is something which has already been decided for you. You're allowed to interact with it, but you're not allowed to change what it refers to. And so a TCP port you can connect, you have your byte stream that you can write to and the byte stream that you get written to, your read end, and that just has, you can call writes and you can end the stream. And so the cool thing about all this is that capabilities make it feasible to split up that giant amount of authority, the ability to connect to any server anywhere and send it any data, and break it down into much, much smaller, much more palatable things that we might want to give to a less trustworthy piece of code. So we don't need to give an IP network to something when a TCP port will do. So if you wanted to connect an app to some third-party service, but you wanted to make sure that that app wasn't phoning home to some other service, then you could give it a capability that only allows it to connect to the one that you trust, rather than the one that you don't trust. So to summarize, capabilities can improve security, capabilities can improve usability. They're pretty great. Use them when you can. If you want to learn more, I have some links to what might be the canonical capability references on the net. And I'll take a couple of questions and then happy to take more questions one-on-one with anyone. Thank you. Questions, thoughts, comments?
So I used to work on the Eventbrite security team. And my question,
What security team?
the Eventbrite security team, and I guess this is being recorded, but I'm just asking this as a fan of capabilities and Eventbrite.
Yes.
And my question is, so if you had a system like Eventbrite where the main identifier for each event is a database auto-incrementing ID number, and you wanted to prevent a category of attacks against those events where people would try to see if AJAX endpoints or things like that would accept the event IDs that you don't own.
If you generated...
How could you capabilityify that?
Okay, the question is, how do you capabilityify a system where you're assigning unique IDs by incrementing an integer? And the answer might be to make those unpredictable. Remember we said that capabilities need to be unforgeable. The attack in what you described
But the world needs to register for these events. The world needs to be able to register for these events, so I can't hide the event IDs.
But you can make them only discoverable through your expected means, right? So the ID, knowledge of the ID is permission to learn about whatever that might represent. But you don't need to make it so that if I show up at your server with the magic ID 42, then that authorizes me to know a thing. I can't come up with one of your IDs without learning it from somewhere else.
Yeah,
Does that answer your question?
Yeah, that could be a start. I'm happy
Okay.
to dig more
So
into
does it mean that you're redefining the access thing to reach to that ID?
I'm not sure I understand the question.
Well, so I have a different summary to your response that might help answer that question.
Okay.
But it sounds like what you're saying is the ID number, for the purpose of the world being able to register, it doesn't need to be the ID number for an admin being able to edit the event.
That's right.
I would agree with that statement.
That's exactly what
Yeah.
I was
Good.
Okay.
So I just want to point out there's one very simple common case where ACLs cannot work. Absolutely cannot work. So let's say that I want to invoke Jade's service. And in order to satisfy my request, she has to invoke Mark's service. So let's say we're using ACLs and I'm going to use my identity. But it could be role or attributes as well. So I use my identity, prove my identity. Jade looks it up, says, yes, Alan is permitted to make this request. Now, in order to satisfy my request, she has to invoke Mark's service. Whose authentication is she going to use? If she uses her own, I might be asking her to do something over there that she's allowed to do, but I am not. She's just become a confused deputy. If she uses mine, she's allowed to do anything I'm allowed to do over there, whether I want it done or not. It's a gross violation of least privilege. ACLs cannot work. They cannot work in this very simple service chaining example. With capabilities, I use my capability to Jade service to invoke it, and I pass as arguments delegations of my capabilities to exactly the resources I need her to use over at Mark's service. Very simple, works very easy.
Like you gave me your car keys.
That's right. But I didn't give you my key ring or my power of attorney or...
To be fair, Apple people have come up with increasingly complicated ways to
Yes,
solve
they
these problems.
get quite complicated. And they don't work. We have confused deputy vulnerabilities all over the place.
Yes.
Well, thank you so much for coming out, and I guess we have open discussion until ThoughtWorks kicks us out at, what is it, 9:30 something?
9:30.
Okay. Thanks again to ThoughtWorks for hosting us and letting me talk with all you wonderful people.
I also want to say thank you. This was a wonderful presentation. The path you took through the concepts to explain it was excellently chosen and very well done.
Thank you.